This dumbass shit. I was trying to go live, so I guess this is just part 2, exercise 8-2, O'Reilly Practical C programming. But I switched the sides of the camera because when there's also I have my retainers in, I have Invisalign, so excuse any lisp, any of that mispronunciation, perhaps. But anyway, yeah, I was gonna go live. I think it would just make sense to do most of these videos live, and then the VOD just be like the video that I uploaded before this. I don't know. We'll see. But I guess I don't have access to stream, so I've had this account for years. I just changed the name of it and then started posting on there, or on here. So I don't know. Maybe it's something to do that, or I had to request access to stream or something. But hey, starting 4 o'clock on Monday tomorrow, I'll be able to stream. So with that said, let's just get into doing some shiz on this exercise 8-2. Actually, I really need to pause the stream or pause the recording, change it to 1080p because that last video you could barely read the text on it. It looked terrible, so I'm sorry about that. But it should be fixed after this. So we're back in 1080p, 60 FPS. Alright, I'm going to stop the recording again. Check that. Make sure I can see this text a little bit better. Probably want to move my camera. Shrink it a little bit because I was kind of covering some of my code. So, yeah, I'm going to stop this, check the recording, make sure it looks good, and then we'll be back. Oh, we are locked the shit in now. I can actually read that shit. It looks good. Hopefully my mic sounds okay. We're just gonna go with it. I see it moving in OBS, so we're cool. Yeah, so this exercise I'm definitely gonna have to start out with some Googling, because I don't know shit about resistance or resistors or I don't know. This shit. Like, what the hell? But, nah, don't even worry about it. We're about to figure it out, so. Oh, my gosh. Okay. Excuse, I should probably close Discord, huh? I don't want to dox anything. Alright, we're locked in now. Just use my website. No, I'm just kidding. Alright, let's learn about what in the hell? Substituting the value, a network of 2 resistors. Network of resistors. Example, I guess. Let's figure out how the hell this even works. Okay, I'm cooked. I'm absolutely cooked. What is this? Holy shit. I'm giving up. No, I'm just kidding. Let's find out. We might have to grok our way through this a little bit just because, like, I don't know shit about shit. But let's break it down to its most intricate parts. Break things down to most intricate parts. Oh yeah.
What are some of your favorite hobbies outside of school?
So we'll go ahead.
It's mostly video game based things. Sometimes I just like figuring out the global intricate mechanics of different systems. Tear something down to its finest parts.
Yeah.
Build something anew from it.
That shit is so tough.
For Fortnite.
PWD, You get this big ass path. I'm gonna minimize that real quick. I hope this format of video is kind of digging into, because I don't know, it's like pseudo streaming, you know, like I'm not the best programmer in the world, right? So I don't feel obligated to just generate dumbass shit that's been said 150,000 times already prior. And not to be someone that's like, how to make a whole Hello World app in Flask with Python. It's like, oh shit, we needed another one of those. So my solution to this is, I'm not the best programmer in the world. Yes, I could probably teach you some things, but it's yeah, I don't have shit to offer, so I'm just gonna make dumb shit like this. Sorry, I'm saying that a lot. Cursing isn't really that cool. But I actually prefer to be in the... Yeah. That's kind of my theory with this content, or my thinking, is that, you know, I'm not the best programmer in the world, but I think I can make some good content to vibe to, and yeah, if you think this format sucks, then just let me know. Sorry, I've been on a 2-day bender. I was hammered the last 2 nights. It's Sunday right now, so this is a part of my reset before going back to work tomorrow. So just let me lube my bearings up, you know. No Modelo's today, just water. But we're going to get it going. So we already did 8.1, CD 8.1. No. Okay. Sorry. All right, we're locking in. Need to create a new folder for 8.2. We're gonna copy this makefile down, and I literally have the add-on for like this, and I was watching myself like program through the last video, and I was like, damn, I am stupid as shit for not just using that functionality in Vim. So yep, that's just the way she goes sometimes. So now we got this, include H. Oh, remember our rule we made last time. I've always been indecisive, you know, and I think just making content like this is going to make me stand on business a little bit more. So, like, I've always been indifferent. Like, these are both okay. This, hell no. This and this, okay. But, you know, I'm team space. What is it? This is like the KNR style. They used it in KNR because it was like from prehistoric times, and like you had to like save space, like line space in the book. So you want to put it on the same line as that. Yeah. I don't know. I just think it's easier to read. Whatever. Let's get our return statement in here, and then let's get back to studying. So the total resistance of N resistors in parallel. So I guess that's what we want to get elaborated on, is this total resistance of N resistors in parallel. So yeah, let's figure something out. Resistors are said to be connected together in parallel when both of their terminals are respectively, like, this doesn't really matter to me, I guess. So 1 over R equals 1 over R. Okay. I gotta blow my nose, y'all. I'll be back. Oh, shit. Oh my god. I hate life. My socks were slick. I almost did a burnout and fell. I'm sorry. Oh. Okay. We're fumbling this video bad so far. Okay. We gotta lock in. So intuitive explanation for parallel circuit resistance. So yeah, 1 over RT. Am I dumb? Like, is this is R to the power of 2? You know what? Sorry, I haven't done math in like 6 years, really. So, write a program to compute the total resistance for any number of parallel resistors. Okay. So I'm really overthinking it. I don't know. But what I do know is that we have a clear, concise. Will this compile? Can I? You can't use inline comments. Let's test it out. Let's make CD8-2. Make. Yeah, that's what I figured. Dumbass shit. Okay. Well, I guess all we wanted to know if it would compile or not. Oh. Sorry, y'all. I'm just ADD as shit, I guess. But look, we support the Swedes around here. We're gonna put a Zen in. I drive a Volvo, so if you're Swedish, just know I fuck with you. But there's one dude I watch on YouTube that's Norwegian. He's pretty cool too. I don't know if they're like ops with Sweden, but we'll see. Write a program to compute the total resistance for any number of parallel resistors. So it tells us total resistance of n resistors and parallel is, so we just need a way to convert this into code. So 1 over R, how do I represent 1 over R, 1 in code? In the context of resistance. So R represents measured in ohms. 1 over R associated with conductance. Okay. Okay, actually, yeah, we're gonna, just because my math brain is so cooked, we're gonna use Grok a little bit here. In the context of resistance and resistors, how could I represent 1 over R, or 1 over R equals 1 over R1 in C code? Resistance in ohms. It really is just that simple, huh? So, okay. We need to definitely need to create. I'm gonna do a float just in case. Write a program to compute the total resistance for any number of parallel resistors. Okay. Okay. See, this stuff is like, I feel like it's so easy, but it's if you're not exposed to this thing often, it's like actual foreign language. So we have float for resistance. A network of 2 resistors. So this is resistance. This is what we are representing. So the total resistance of our... Let's... Oh God. Let's focus on representing the example one over R equals 1 over R1 plus 1 over R2 So this is not to the power. This is just saying, hey, this is resistance 1 that we were provided, and then 1 over this is resistance 2. We're going to substitute in these values here of 200 and 400. So in place of those, that's what we're going to substitute. So 1 over 200, 1 over 400 plus 1 over 200 equals 400 divided by 3. So, okay. So what this is what we're given. 1 over... Okay, resistance is equal to 1 over 400 plus 1 over 200, which equals 3 over 400. How in the hell do I calculate that? One over 400 plus 1 over 200. Explain. Okay. We don't want to see the code. We just want an explanation of interpret as a mathematical expression. You're so smart, Grok. Thank you. 1 over 400 means 1 over 400, the reciprocal of 400. 1 over 200, blah, blah, blah. Expression, sum of these two fractions. This could relate to your previous question around resistance, so don't worry about that, big bro. To add 1 over 400 and 1 over 200, we need a common denominator. The denominators are 400 and 200. The lowest common denominator is 400 because 200 goes into 400 evenly. Okay. Holy shit, I'm actually burping, snotting, sneezing, lisping. Look, I got 2 subscribers from my last video. If I lose both of y'all, I completely understand. 1 over 400 already has 400 denominators, so it stays that way. So we need to calculate the lowest common denominator of all the resistance value of the resistors. Okay. Yeah. Okay. Where R1 is, so we definitely need int resistors. Let's put it at 10 for now. It's going to be our array of resistors. So where R1 equals 400, where R2 equals 200, we would do 1 over 400 plus 1 over 200. Find lowest common denominator. 200 goes into 400 evenly. 400 is LCD. So it stays. Okay, where the fuck did the 2 come from? So 1 over 400, rewrite the fractions with the common denominator. So that becomes 2 over 400. Okay. You know, I think part of my brain has trouble being like, okay, but why? Why are we multiplying them by 2, turning it? But I guess in math, it like stop asking questions and just start following instructions, right? I mean, we know the formula, so let's not harp on that too much. 200 goes into 400 evenly. 400 is lowest common denominator. So it would be rewrite the fractions with the common denominator. So we've got to do it to the top. So since we have to rewrite, yeah, I mean, okay. 1 over 200 rewritten would be 2 over 400. So now we add that. Okay, that makes sense. That makes sense. I'm really stupid. It's been a while since I've done this, and the context of which it's brought up in was a little bit more intimidating than like, hey, we're gonna be doing freshman year high school math. So, okay. We need to think about how we need to calculate resistance. So resistance is going to equal what? Resistance equals resistor 0, for example. So let's just test it with the example. Resistor 0 equals 400, and then yeah, 1 equals 200. Okay, so we've got that. Do we want to return it as a fraction? So the total resistance for our 2, okay. This is a banger. Okay, now we understand what all happens. So if one resistor has a resistance of 400 ohms and another has 200 ohms, the total conductance G of the two in parallel is G equals 3 over 400. So, okay. We'll be able to represent that's how many Siemens. Whoa. Simons? I'm going to say Simons. The equivalent resistance R total is reciprocal. So in order to get resistance, we're going to have to get the reciprocal. So let's just... Let's just get the... I don't know. Float fraction sum. Is sum fractions a thing? Is that the right term? Whatever. We need to get the sum of these fractions. So fraction sum is going to equal resistors 0 plus resistors 1. How do you represent that in code? We put it over 1, so it would be so we can do float here. It's going to implicitly convert to a float, right? I think. Okay. We're getting a number. 0075. That's what we got, right? Yeah. Oh! I'm the GOAT! Okay. But now, in the context of resistance, sorry, we're processing here. So we're getting the right value on that. I'm just wondering. I'm not looking at the code. Walk me through binding the resistance. Okay. We can confirm using parallel resistance formula. Okay. Oh my god, I love AI. Let's walk through finding the equivalent resistance for the scenario where we have 1 plus 1 over 200, 1 over 400 plus 1 over 200, blah, blah, blah. And the equivalent resistance is the reciprocal of that conductance. So, identify the problem. The expression suggests the formula for total conductance is blah, blah, blah. Our goal is to find the equivalent resistance of this parallel combination. For resistance in parallel, the total conductance, G total, is the sum of the individual conductances. So, okay. Yeah, that's a period, I guess. The equivalent resistance, R total, is the reciprocal of the two conductances. So we put 1 over... What? We put 1 over the fraction sum. So resistance, this equals 1 over fraction sum. There's no way. Oh, okay. Cool. Okay. For any number of parallel resistors. Okay. The thing is this past exercise taught me a lot about cases, but I'm like, why the hell would I use cases at any point in this? Maybe I don't know enough about it to really implement a case. Okay, it's all cool. We're all cool. We're all cool. So I guess now we can just say we want to do it with any number of parallel resistors. So for for the length of an array and see. Size of, okay. So fraction sum plus equals one over resistor I Let's see if this gives us the same. Okay, cool. It does not. Inf. Yes, I realize I'm not being the most efficient while looking through my past code. Let's look at while loop. Okay. So, what are we finding here? Why is that saying imp? Okay, this isn't how math works, I guess. So fraction sum is just going to hold this. Then we're going to go up here and do float. Is this going to give us what we want? we're getting what we want again. We need to figure out how to make this. So that was running just over and over and over again because the size doesn't necessarily refer to, you know what I'm saying? So resistors is going to be 10. If we make it size of resistors, it's going to run 10 times. And it's just going to screw everything up. So how do we make this dynamically? The only way I can think about doing this is with command line arguments and doing like, you know, running over only up until the amount of values given. So we're just going to do that shit because I don't really know of any other way to do it. Int arg C. Okay. Yeah, we need to look. Look how beautiful that is. Boom. Char star arg V. So we want to instead of having our resistors, we'll get rid of resistors and use arg V. Fuck that shit. Only to the amount of arg C, then arg V, and char star. Is this gonna work? No. Shit, my life. How can we abstract the argv into... Can we define an array of float resistors with the amount of argc? So equals, and then we'll populate this for I equals 0, I less than argc, I plus plus, boom, and then we'll populate this. We'll say resistors I equals A2I argv I. What in the hell? Okay. I want to say that A to I is in the standard lib. Can't remember. Oh yeah, we're cooking with fucking peanut grease. So now we have resistors. Does this give us what we want? Fuck no. Passing float. I'm stupid. Hi, Python brain. Oh. It's because I'm not giving it any value. I'm really stupid. Okay. So wait, what is it printing the 00? I'm getting a divide by 0 error because for some reason. What if we started at 1? Is it because of like a null byte or some shit? It's exactly what it fucking was. Alright. Now it's working. So now we can give it however fucking many we want, I guess. 600. Okay. I don't feel like doing the formula to check if that's correct or not. Excuse me. But okay. Yeah, I'm gonna call that good. For sure. I actually spent a lot less time on this than I had imagined I would initially. Yes, we use Grok. But yes, I don't know shit about formulas and shit with resistance, okay? So leave me alone. We didn't cheat from the code. Okay. But we learned some stuff, so that's all that matters. But hey, thanks for watching and all that shit. More is to come. Next program, we'll probably do a multiple. We'll probably do maybe a stream next and try to hammer out a few of these, and then we're on to reading this next chapter, which I might do on a stream. I don't know. But then we've got the 9.7 exercises, which will be fun. But yeah, thanks for watching. Let me know if I should stream or just never think of doing that again. All right. See y'all. Y'all be safe. Peace.